Welcome to the DIY Honda Garage channel. The DTC P1298 indicates a high voltage scenario in the ELD, or Electronic Load Detector circuit, for the Honda Odyssey models from 2011 to 2017. An electronic load detector is critical for monitoring the electrical load on the vehicle's electrical system, helping to manage battery usage and overall vehicle performance. When the DTC is triggered, it indicates that the ELD is detecting a voltage level that is higher than normal, which can lead to various electrical issues if not addressed. The location of the ELD is usually near the fuse/relay box or integrated within the vehicle's electronic system. Before beginning troubleshooting, it is important to record any relevant freeze data and onboard snapshots that could provide insight into the issue. This is also a good time to review general troubleshooting fundamentals to ensure a systematic approach to resolving the code. DTC P1298 signifies a problem with the electronic load detector, which is responsible for monitoring the amount of electrical load that the car's charging system must manage. This component is essential because it helps the vehicle's computer determine how much power to allocate to various systems when the vehicle is running, thus ensuring efficiency and reliability in electric load management. When a high voltage condition is noted, the ELD may be falsely signaling that there are issues with other electrical components. The ELD itself is typically situated near the fuse/relay box, making it relatively accessible for inspections. A malfunctioning ELD can lead to draining the battery too quickly or not managing power to systems correctly, which could manifest into other electrical failures. Several potential causes may lead to the P1298 diagnostic trouble code. A faulty ELD is one of the most common reasons. If the unit has failed electronically, it may report incorrect voltage levels. General electrical failures could result from poor connections or loose terminals at the ELD or the powertrain control module, PCM, preventing reliable communication. Open circuit faults can occur when the wiring between the ELD and other modules, like the PCM, experiences a break or damage, leading to abnormal readings. These causes require immediate attention to avoid further electrical issues in the system, as they can cause cascading failures that may affect other components. Symptoms associated with DTC P1298 can manifest in several ways. One of the most immediate signs is the electrical load issues, where various car components may not receive the power they require, leading them to malfunction. Drivers may also encounter faster battery drainage as the ELD plays a crucial role in power management. Furthermore, system performance degradation can be observed, resulting in various warning lights illuminating on the dashboard, signaling to the driver that something requires attention. It is essential to address these symptoms promptly to prevent further complications within the vehicle's electrical system. Remember, these symptoms can sometimes overlap with issues from other components, so careful diagnosis is warranted. The first step in diagnosing DTC P1298 involves starting the engine and allowing it to idle. This allows the vehicle's systems to reach operational status and enables accurate measurement of the electronic load. After the engine is running, the next action is to check the ELD using the HDS, or Honda Diagnostics system, to see the current reading. A suitable reading is 0.2 amperes or less, indicating that the ELD is functioning correctly at this time. If the reading exceeds 0.2 A, it suggests that there might be intermittent faults. This check is crucial, as it helps determine whether the ELD is operating correctly or if further investigation is necessary into wiring or connections related to the system. For the second troubleshooting step, turn the ignition switch to the lock position. which safely powers down the vehicle's electronics before conducting any disconnection of components. The next step involves disconnecting the ELD 3P connector, which is the 3-pin connector associated with the electronic load detector. It is important to ensure that the connection is properly disengaged to avoid damage. Once the ELD is disconnected, turn the ignition switch back to the on position. This step is crucial because it enables you to check the voltage present at the ELD without the influence of the component itself. If the system shows no voltage, it can aid in narrowing down where the issue lies. In the third step, measure the voltage between the ELD 3P connector terminal number 3 and body ground. This check is vital as it determines whether the ELD is receiving proper voltage from the battery. You should expect to see battery voltage present. If so, you then proceed to the next steps. If no battery voltage is found, it indicates an open circuit in the wires leading back to the number C24 ACGA S15A fuse in the driver's under-dash fuse relay box. Identifying this open circuit is crucial because it suggests that power is not reaching the ELD, leading to a high voltage reading and triggering the diagnostic trouble code. Once this step is completed, necessary repairs to the open circuit should be made to ensure continuity in the electrical system. After ensuring the voltage issue has been checked, turn the ignition switch back to the lock position for safety. Next, use the HDS to jump the SCS line. The SCS, which stands for the Serial Communication System, is involved in the communication between various vehicle components. Jumping this line is necessary to facilitate further testing without erroneous signals affecting the diagnosis. The final action in this step is to disconnect PCM connector A, specifically the 49-pin connector. This step allows for the examination of the continuity of connections between the ELD and other modules. Ensuring proper disconnection prevents shorts and prepares the systems for accurate testing in the following steps. The last step involves checking for continuity between the PCM connector terminal A10 and ELD 3P connector terminal number 1. This test is essential to determine if there's an uninterrupted path for the signals to or from the ELD. A lack of continuity here would indicate either a faulty wire or connection between these points, which will contribute to triggering the P1298. It's crucial to ensure that the terminal numbers are correct during this verification step, as misidentification can lead to erroneous readings and misdiagnosis. By confirming connectivity, repair strategies can be better formulated. Consequently, if continuity is found, the system may be considered for further checks, while a lack of continuity leads to prioritizing repairs to associated wiring or terminals. After completing the necessary repairs, it's important to conduct a final verification to confirm that the issues associated with DTC P1298 have been resolved. Begin by checking all connections and ensuring they are properly secured, as loose or poorly connected terminals can lead to a recurrence of the error code. Following this, clear any diagnostic trouble codes using the Honda Diagnostics System tool. This step resets the vehicle system and prepares it for a fresh evaluation. After clearing the codes, take the vehicle for a test drive to examine its performance under regular operating conditions. Monitor the dashboard for any alerts that may indicate a re-trigger of the P1298. If no issues arise during the test drive and the vehicle performs well, you can conclude that the repairs were successful. To prevent future occurrences of DTC P1598, establish a regimen of preventive maintenance practices. Start by regularly checking the ELD connections, ensuring they remain tight and free from corrosion or dirt. It's also wise to routinely inspect related wiring for signs of damage, fraying, or wear. as these can lead to more significant electrical issues. Performing scheduled diagnostics can help identify potential issues before they escalate into errors. Additionally, maintaining the health of the battery and electrical system can diminish stress on the ELD. Following these preventive measures will contribute to a longer lifespan of the vehicle's components and a more reliable driving experience. In conclusion, diagnosing and resolving DTC P1298 requires a methodical approach, following systematic steps laid out for effective troubleshooting. Understanding the role of the electronic load detector and ensuring all connections and circuits are intact is critical to the resolution. After implementing repairs, thorough verification is necessary to confirm that the issue has been resolved satisfactorily. Lastly, embracing preventive maintenance will minimize the risks of future abnormalities, ensuring a smoother and more reliable operation of the Honda Odyssey's electrical systems. By committing to regular checks and timely interventions, you enhance your vehicle's performance and longevity. This comprehensive troubleshooting guide aims to empower technicians and owners to tackle issues related to the ELD effectively. Please like and subscribe to the channel. See you next time!